In this tutorial, we're looking at Leaving Cert Higher Level 2023 Paper 1 Question 8. And it's all about financial maths. For the first part of this question, if you're rusty on it, look at Financial Maths 2. It covers this kind of content. For part A, we're simply told that Olga invests €3,000 and that the interest rate is 2.4% per annum. We're asked to work out how much is the investment worth after 5 years. So you should just go to your maths tables and get the compound interest formula. It didn't specify what kind of interest, whether it was simple interest or compound interest, so we can assume it's compound interest. P is the amount invested, it's 3,000. I is the interest rate, but remember you divide it by 100 to get it as a decimal, and T is the number of times interest is applied, in this case 5. When you plug into your formula, your answer works out as 3,377.70. In B part 1, we're asked to explain what is the present value of a future payment of €1,000 in 1 year's time. So in other words, if I told you that I'm going to give you €1,000 in a year, what is that worth to you in today? Like, what would that be worth to you today? And it's not worth €1,000 because you have to consider interest. So the way to describe what it means is this. How much money must I invest in order to have €1,000 in 1 year at whatever interest rate is relevant? In other words, let's say that you have €950 in a bank account today, and whatever your interest rate is, in a year's time, you're going to have earned €50 interest on it, so that €950 in a year will be worth €1,000. That would mean that if I told you I'm going to pay you €1,000 in a year, that's only worth €950 to you today. You'd actually be better off if I gave you €960 today, because €960 today would become more than €1,000 in a year's time. So that's the principle, that's the concept they were seeing did students understand. In B part 2, we're told that Chen invests money into an account. He leaves the money in the account for 6 years at an interest rate of 2.4%, and at the end of the 6 years, it's worth 4,000. And we're asked to work out how much did he initially invest. So if you go to the financial maths page in your maths tables and you go to the second formula, it's the present value formula. It's actually exactly the same as the formula we used in part A, it's just been moved around. We've just manipulated it so that P is on its own rather than F being on its own. All we have to do is sub in. The final value is 4,000, the interest rate is 0.024 and T equals 6. And if you plug that into your calculator, this must be the amount of money that Chen invested in the account originally. In part C, we're told that Fiona is taking out a loan and that she plans to make quarterly repayments. The annual interest rate is 2.4%. So we need to figure out what is the equivalent quarterly interest rate. So the way I'd always set this up is that the yearly interest rate to the power of 1 equals the quarterly interest rate to the power of 4. We can represent the yearly interest rate as 1.024, or in other words 1 plus I, but I know what the I is for the annual interest rate. And for the moment, the quarterly interest rate is 1 plus I to the power of 4. And I just need to solve this equation now to work out a value for I. So the first thing you want to do is get rid of this power, so you get both sides to the power of 1/4. And you end up with 1 plus I equals 1.024 to the power of 1/4. Plug that into your calculator, and 1 plus I is equal to 1.0059467. We're only interested in the interest rate, so you can subtract the 1 from both sides. And finally then you're asked to leave your answer as a percentage to 2 decimal places. In other words, you move the decimal place 2 places here, and the percentage is 0.59%. In part D, we're told that Rowan is investing money. He's going to invest the same amount of money at the start of each month for 36 months. We're told the interest rate is 0.11%. And at the end of the 3 years, Rowan wants to have €12,000 in the account. We're asked to write out a geometric series to represent this, showing the first 2 terms and the last 2 terms. Now, we've practiced loads of questions like this in Financial Maths 6, so if you're rusty here, make sure you go over that video. I think it's the longest tutorial on the whole course. I think it's about an hour and a half of just questions like this, so it's really worth your while looking at that one. Essentially here, when we're saving money, we're repeatedly subbing into the compound interest formula. What I want you to think about is we're repeatedly subbing into this formula. So for the very first time that Rowan invested money, let's start with that one. We're told that we have to represent the amount he invests as A. The amount he invested at the very start will be in the account for 36 months. So that means it's going to earn the interest rate 36 times. So the first investment will be 1 plus I. I, in this case, if the interest rate is 0.11%, then I, if to divide that by 100, I is 0.0011. So don't forget to change that. You're not using 0.11, you're using 0.0011. So the 1 plus I in this case would be 1.0011. And the first investment remains in the account for 36 months. So the first investment earns that interest rate 36 times. So that's the first term, and I want you to realize basically I'm just subbing into this. The second term refers to the second investment, which was made 1 month later. So obviously it's exactly the same. The only difference is that it only earns the interest rate 35 times. So again, I'm just subbing straight in there, and the only thing that changes here is the powers. So then there's going to be a whole bunch of other terms, but they didn't actually ask us to write them all out. So now we just need to write the last two terms. The second last term will only be in the account for 2 months. So that means it's A times 1 plus I to the power 2. And the final investment is just goes into the account at the start of the last month, so he only earns interest on that once. So basically there's 36 terms, they look very similar. The only thing that changes each time is the power. And each time we're subbing into that compound interest formula. And Rowan wants all of these terms to add up to 12,000. So that's the geometric series that they were talking about. In part 2 then, we're just asked to solve this. So remember, this is a geometric series. And we want to use the formula Sn for a geometric series to solve this. So this is the formula we're trying to use. Sn, all of the terms are going to have to add up to 12,000. Whenever we have a geometric series like this where we're saving money, the common ratio is always just 1 plus I, in this case 1.0011. And A, the first term, you have to be careful here. Remember that when we're doing questions like this, we don't want to take this as the first term because that's the most complicated term. I want you to remember that 1 plus 2 plus 3 is the same as 3 plus 2 plus 1. So if I just wrote these 36 terms on the left in the opposite order, then this would be the first term, and they still add up to the same thing. So that's the catch that you can't forget. We use the last term as the first term in these scenarios. So the last investment is actually going to be our A in this case. Or is just 1 plus I, and Sn is 12,000. All we're going to do now is sub into the formula, and we're going to work out a value for capital A, which is the amount of each investment. Remember as well that n, the number of terms in this case, is 36 because the number of monthly investments is 36. So again, I'm using my Sn for a geometric series formula. I have Sn, I have A, I have OR, and I have N. So what I've done in this line is I've just subbed it all in. And when we do that, we only have one unknown, it's capital A. Now you can actually do the calculator work very easily here. The way I want you to imagine it is you can kind of like factorize out the A, everything else. You can factorize out the capital A and everything else on the right hand side are just numbers. So you can plug all of that straight into your calculator. When you do that, you get 36.74209. If you divide both sides by that number, you end up with your final answer, A. The amount that Rowan has to invest at the start of each month for 36 months is €326.60. In part E of this question, we're told that a park sells 3 types of tickets. It sells children's tickets for €11, it sells adults tickets for X euro, and it sells student tickets for 5 less than an adult ticket. We're told 52% of people that go to the park are children, 15% are students, 33% are adults. We're told that the expected value of the cost of one of these tickets is $13.85. We're asked to work out the price of an adult ticket. If you're rusty on your expected value, this is what we studied in probability 9. So it's worth looking back over that. In probability 9, we explored the formula for expected value. The formula for expected value is you take the value and you multiply it by the probability. And you do that for each thing and you add them all together. So it's quite straightforward to work out the expected value, which is usually represented as E of X, and that's what I've put in here. Let's start off with the children. The value of a child ticket is €11. And the probability, if I randomly selected these tickets, the probability that it's a child ticket is 52%, which we can represent as 0.52. So that's the expected value of that ticket. but I want the expected value of, I want to work out what is the expected value of any ticket. So I just have to repeat this process for adults and students and add all three of them together. The expected value, let's start with an adult. The value of an adult ticket is X euro, and the probability of an adult ticket is 0.33. So there's the second one. The third one we're looking for then is a student. Well, if adults are worth X euro, students are 5 less than an adult. So obviously to represent the value of a student ticket, it's going to be X minus 5. So that's the way you should really be viewing the value of a student ticket. And the probability that you get a student is 15% or 0.15. So there we've subbed in basically to our formula for expected value, and that's what you'd get with it. I know that this expected value has to add up to €13.85. So now I have an equation that has only one unknown. So if you get this far, it's relatively simple now. We're going to simplify this down and work out a value for x. So all we have to do is simplify now. The first line here, I multiplied 11 by 0.52 and got 5.72. X by 0.33 is 0.33x. Here I multiply out the brackets, you get 0.15x minus 0.75. And on the next line, I just grouped my like terms. If you add those together, you get 4.97. If you add your x's together, you get 0.48. I brought all my non-x terms to the left and then divide both sides by 0.48, and your final answer, the price of an adult ticket, is $18.50. In the final part of this question, we're told that markup is equal to profit over cost price by 100 over 1. Likewise, we're told that margin is equal to profit over selling price by 100 over 1. We're told that for a particular product, the margin is 18%. And we're asked to use this information to work out what the markup is. Well, first of all, 18% is equivalent to 0.18. So that allows us to get rid of the 100s. We can just say that profit over selling price must be 0.18 and that markup is profit over cost price. And now we're going to be able to work out what the markup is, and at the end we'll multiply it by 100. The first thing you should recognize is what the selling price means. If you have a selling price, there's two components to the selling price. Let's say that I own a shop and I'm selling a pair of runners. The selling price of those runners is composed of the cost price. How much did I buy these from my distributor? How much did it cost me to buy them for? And how much profit am I going to make off them? So the first thing you have to recognize is that selling price is simply the cost that the shopkeeper spent on the product plus the amount of profit they're making. And that's beneficial because now there's a lot less variables. In order to make life a little bit easier here, I'm going to start referring to profit as P and cost price as CP. And essentially we're looking for the markup. So we're trying to find what is P, the profit, divided by CP, the cost price. And if I do the same thing here, I can say that 0.18 is equal to the profit, which is P, dividing by the selling price, which is actually simply the cost price plus the profit. So now all I need to do is try and manipulate this. I'm going to try and isolate either P or CP. And when I have CP or P on its own, I'm going to sub it in to the fraction for markup and I'll get my final answer. So first, I need to simplify this equation. I want to get rid of the fraction. So I'm going to multiply both sides by CP plus P. If I multiply the left-hand side by CP plus P, I'll get 0.18 times CP plus P equals P. Now if you multiply at the left, you'll get 0.18 times the cost price plus 0.18 times the profit must be equal to the profit. Now I'm going to try and get CP on its own here. So all I need to do is subtract 0.18p from both sides. So I'll leave a 0.18 CP on the left, and on the right I'll have 1p minus 0.18p. And now if I do that calculation, I have 0.18 CP equals 1p minus 0.18p, which gives me 0.82p. And now I want to get CP on its own. It doesn't really matter whether I isolate P or I isolate CP, but I have to randomly choose one of them. So I randomly choose to isolate CP. I'm going to divide both sides by 0.18. If I get 0.82 divided by 0.18, that gives me 41 over 9p. So now I finally have the cost price relative to the profit. And if I have that, I can go back to the original equation. Originally, I was told that markup is equal to profit over cost price. But now I know that I can actually write that, well, the top of the fraction is 1p, and the bottom of the fraction, instead of the cost price, I can put in 41 over 9p. So that's just 41 over 9p. Now, obviously, this is what I wanted all along, because the p on the bottom and the p on the top cancel each other out. And now, if you plug this into your calculator, 1 divided by 41 over 9, that gives you 9 over 41. And all we have to do now is get this as a decimal and as a percentage. So if we multiply this by 100, our final answer is that the markup is equal to 22%.